Hey there everyone, we're now in our next video in the introduction to statistics, and in this video we're going to talk about the applications of standard deviation as a measure of variability. Now we know and we have talked about that standard deviation is the standard as the name itself dictates in the measures of variability. It's the most stable and the most commonly used with together with the mean. So there's a lot of applications of it, and we're in this video we're going to talk about in particular the coefficient of variation as the application of standard deviation here. So the coefficient of variation is a relative measure of variation. This is when you're comparing one relative to the other. So comparing one with okay or relative to the other expresses the standard deviation as a percentage okay of the mean, and it is expressed or being expressed in percent can be used to compare variability of two or more distributions. When, number one, observations are expressed in different units of measure. So even though the units of measure are different, we can still measure the the variability of two or more distributions. Or if the data sets being compared have different means. So even if the means are different, we can still tell which one is more variated or dispersed or more clustered than the other. So what is our rule of thumb? The greater the coefficient of variation is, the greater the variability or the dispersion is. Okay, so the greater the CV, the greater the variability. So what is our formula for our coefficient of variation? So the CV is equal to the standard deviation divided by the mean times 100. It should be the mean here. It should be x bar. I'm sorry about that. Okay, so it should be x bar. So the standard deviation divided by the x bar, the mean, okay, times 100%. So again, SD divided by mean times 100%. So let's do this. So let's just example or notes before we go to some practicalities. There are these are the terms that we will be using interchangeably. I have been telling this or saying this in the first parts of the video. More uniform, more homogeneous rather, more compact, less dispersed, less scattered, less variable, less heterogeneous, and less varied. So these terms are very much synonyms. Okay, so they're very much synonyms. Some remarks um, in the business statistics in the investing world, when you're having business statistics right now, in the investing world, the coefficient of variation allows you to determine how much volatility, okay, volatility or risk, okay, you are assuming in comparison to the amount of return you can expect from your investment. Again, the CV allows you to determine how much risk or volatility you are assuming in comparison to the amount of return you can expect from your investment. So in simple language, the lower the ratio of SD to mean return, that is your CV, the better your risk return trade-off is. Okay, so let's see some examples, shall we? So example number one. So consider the two investment proposals. We will call them A and B for simple naming. And the following data shows us this. So we are asked to find which one is better than the other. Okay, which has low, um, a better risk risk return trade-off is or has, and we're going to have okay the CV for each proposal. So let's have it. For letter A, again, remember in A, the CVA formula is equal to your SD, your S, all over your X bar or your sample mean. Multiply this to 100%. So this is your coefficient of variation, right? 100%. 0%. Okay. Now let's have A first. This is what's CV of A. Let's call that CV subscript A, shall we? So the answer would be this SD. The SD of A is 107.07. So what we have is 107 oops, 107.07. Just a minute. Let me erase that. 107.07 all over 230 times 100%. Okay, so we'll be using our calculators and try to answer this. So let's have it. So I'm using my calculator right now. So 107.07 divided by 230 times 100, it will give us 46.55. Can we make it in the integer in the least integer? So that's 46.55. Let's write it down. 46. That's a 4.55%. Okay, and we can say and make it to the round it off to the nearest integer. So what we have is 47%. Okay, 37%. So that's for letter A. How about for letter B? So let's solve it. CV of B. Okay, this is equal to the SD of B, which is 208.57. So 208, 208, 208.57 all over 250 times 100%. Sorry for my penmanship. Okay, let's have it. I will be using my calculator likewise. So what we have is 208.57 divided by 250. It will give us an answer of time is set to 100. It will give us an answer of 83.43. Okay, 83.43%. So let's round it off also to the nearest integer, which will give us 83. Okay, now what does this tell us? Okay, what does this tell us then? So, because the coefficient of variation is a relative risk, okay, or a relative measure of risk, B is considered to be more risky than A, although B has a greater mean, a greater expected value, greater returns, shall we say, because the mean is 250 pesos, than A, which is only 230 pesos. But B is considered a more risky investment. Since B is more volatile than A. Meaning your earning in B can vary from, okay, what we're going to do, how do we know how it will vary? Look at this. Our mean in B is 250, but the standard deviation is 208.57. Meaning to say, we will have something like X, the X bar, the mean, plus and minus your standard deviation. That will be your expectation. Most of your it is expected that within that interval, you can have that expected value. You cannot get an exact mean of 250 all the time, right? In any investment. So you will have 250 minus 28.57 is going to give you um it's going to give you 41.43. Let me try that. So 250 minus 208.57, that's 41.43 pesos. Write it here. 41. So in the minus SD, so we have 41.43 pesos. And for the plus, meaning this is your interval, And for the plus, what you're going to do is plus it. What you'll have is 458. 458.57 pesos. So this is your interval for B. But how about for A? What are your interval for A? So for the minus for A, so what we're going to do is 230 minus 107.07. So the answer is 122, 122.93, 0.93 up until, let's do the calculator again. So plus 230 plus 107.07 is going to give us 337.07. So 337, 337.07. Okay, so you can see that the interval, what are the meaning of these numbers then? Well, your earning in B can vary from 41.43 pesos to 458.57 pesos. So it's quite, you can get a value or an expected return of 40 pesos, as low as 40 pesos or 45 pesos at least. While for A, you can have your smallest income to be more than 100, exactly 122 or 123 pesos from 337 pesos. Though you can see that you can reach a more greater income in proposal B, but it's risky because you can get as low as 41 in B, while in A, you can only have the lowest as 122, only that your highest is 337. Thus, the greater the CV is, as you can see, 83 percent is here, the more variable the data of the group is. Okay, the more dispersed it is. Okay, so that's for our example number one. For our example number two, okay, let's have this. So the weights of 10 boxes of a certain brand of cereal have a mean content of 278 grams with a standard deviation of 9.6 grams. If these boxes were purchased at 10 different stores and the mean price per box is 64.50 pesos with a standard deviation of 4.50 pesos, what or can you conclude that the weights are relatively more homogeneous than the prices? So are the weights more homogeneous, the same, in which it means it's less scattered or more clustered than the prices? So let's see, we can get that using or solve first or solving for the coefficient of variation of the weights versus the coefficient of variation for the prices. Okay, let's do that. So CV for the weights first. CV, which is for variation of the weights. Okay, so for the weights, again, it's SD over mean. So the SD of the weights is 9.6 grams. Let's write it down. Okay, and then the mean content is 278 grams. So 278, 278 grams. We're going to multiply that by 100. All right, so times 100.
It's 12 o'clock.
So it's times 100%. So maybe we can get the answers directly now since we'll be rounding it off to the nearest integer. So what we have is 9.6 divided by 278 times 100. It's going to give us 3.45. Okay, it's going to give us 3.45, and which will eventually give us 3 if we want to read to put it in the nearest integer. So that's going to give us 3%. All right. So how about for the prices? So let's write the CV for the prices here. Let's call it CVP. So the SD of the prices is 4.5. Let's just write it as 4.5 over here. And the mean of the prices is 64.5. 64.50 is more like 64.5, right? Okay, times 100%. Times 100%. Okay. Okay, so let's have it. 4.5 divided by 64.5. The answer is times 100 is 6.98, which will, if we want to run it off to the nearest integer, it's going to give us 7%. 7%. 7%. Okay, so as you can see, the prices has a more CV than the weights. Hence, the answer is yes. The weights are relatively more homogeneous or more clustered. It's less scattered or less variated, less dispersed than the prices because CV for the weights is less than the CV for the prices. So that's our answer for the question or for the problem above. Okay, so that's it for this video in this application of variation. Um, Application of standard deviation rather. That's the coefficient of variation part one. So I'm going to see you next in the next application. Um, that will be the Pearsonian skewness. Okay, so it's just the end of the coefficient of variation, by the way. So that's it for today. Thank you very much for watching, and I hope that you would like and subscribe. Okay, thank you.